Okay, we're going to start with number 12 here. This is the second half of the Common Assessment Review. Number 12 says find the zeros of this polynomial function. So we're going to do this on the calculator. Because sometimes you can see them all. Just so you know, there are 5 of them. Is that x to the 5th? So if we can see all 5 of them, then we won't do any extra work. So let's see what we have. X to the 5th plus 4x to the 4th. Oops, I already messed up. See what I just did? Let's try this again. X to the 5th. I always have to remember to press that right arrow. Plus 4x to the 4th arrow. Plus 6x to the 3rd arrow. Plus 18x squared minus 27x minus 162. Okay, let's see. I'm going to press zoom 6 because my window was messed up from the last graph. So press zoom 6 to get to a 10 by 10 screen. Ooh, interesting. Ooh, okay. So this is, it's kind of seeing the end, you kind of see the end behaviors here. I mean, you could maybe expand this to see if it's coming anywhere else, but I don't think it's going to. I think I can see 3 roots. Can you guys see 3 roots? There's 1, and it looks like a 2. This one looks like -3, but this one right here looks like a double root. -3 double root because it just touches, and this one is a 2. So let's just check the t-table to see if those are actually numbers. That might work. There's the 2. You see the 0? That works. And let's check out that -3, and there's 0. I mean, you can scroll and make sure there's no other zeros, but these numbers are getting pretty high. So it looks like -3 and 2, but the -3 has a double root factor here. So let's remember this. We have -3 and 2. Okay, so there's 3 of them. So we need 5 answers, which means the other 2 are imaginary. And the only way that you can get to the imaginary is to do synthetic division with these 3 numbers. And then the quadratic that's left, you can set it equal to 0 and solve and get the imaginaries. So I don't have a whole lot of room here, so I'm going to try to squeeze this in. So we're going to go -3. Let's go 1, 4, 6, 18, -27, -162. I kind of think the one on the test is a missing term here. So remember, if there's a term missing, you know how it's x to the 5th, 4th, 3rd, 2nd. If there's a term missing, you have to fill in a 0. Don't forget that. Okay. So we have 1, -3, and plus you're supposed to get a 0 remainder. We already saw that it works on the calculator, so we should definitely get a 0 remainder. If you don't, then maybe you'll go back and fill in a 0 if you need it. All right, so 1 times -3. So that's 3. 3 times -3 is -9. Add 9. 9 times -3 is -27, which is -54. And -54 times 3 is positive 162. First 0. So we should get a 0 because we already saw that they are zeros. I'm going to do the -3 again because it's a double root. I'm going to try to squeeze this in. 1, -3. If you add, you get -2, 6, 9, -27, -18, and 54, which is my second 0. All right, so what I'm going to have to do, because I'm out of room, is I'm going to have to turn my paper sideways and do the synthetic division. So what we had left was a 1, a -2, a 9, and a -18. And I'm going to do my third root 2 with these remaining 4 numbers. Remember, we started with 6. Then we had 5. And now we're down to 4. So this is so we started with quintic, and then this was quartic, so this would be cubic. So bring down the 1. 1 times 2 is 2. Add, get a 0. 0 times 2 is 0. 9 plus 0 is 9. 9 times 2 is 18. Third 0. So what we're going to do with the remaining, this is quadratic. When you've got 3 roots out of 5, there's 2 left. So this 1 is a 1x squared plus 0x plus 9 equals 0. And if you subtract 9 to the other side, you get x squared equals -9. And if you square root, you get plus or minus 3i. Those are our other two answers. Someone come bring those over here. We have plus or minus 3i. That's 2 roots. 3, 4, and 5. There are our 5 roots. Come here. Come here. Come here. My dog wants to say hi. Say hi, Snowball. She's okay. So 13. We're going to use the sum or difference identities to evaluate. Now, on your test, I will give you the identities, but for now, I'm just going to tell you what they are, okay? So I will give you a little sheet of formulas for the test tomorrow. So when you have sine sum, it's sine of the first angle, cosine of the second angle, and then with sine, you always have the same sign, plus. If that's a plus, this is a plus. And then it's going to be cosine pi sine theta. Remember that? So the sine of pi is 0, because pi is -1, 0, the order pair. So sine is 0 times cosine of theta plus cosine of pi, which is -1, times sine of theta. Well, 0 times anything is 0, so this is gone. And so your answer should be negative sine of 0. See my dog? She's listening to me teach here. All right. Cosine is cosine theta cosine pi over 2. Do both angles, both cosine. But when this is a minus in cosine, this is a plus. And then you have sine theta sine pi over 2. I know this is hard to see, but I'm in bad lighting here. Let's see if I can try to focus this in. All right, anyway, cosine of pi over 2. Pi over 2 has an order pair of 0, 1. So the cosine of pi over 2 is 0. So this is cosine of theta times 0 times sine of theta times sine of pi over 2. Sine of pi over 2 is just 1. So this is 0. So your answer should just be sine of theta. What is the sine of 150? This is practice some unit circle stuff. 150 has to do with 30 degrees. So 30 degrees starts with a 3, so this is a 1/2, and it's positive because it's in the second quadrant. Cosine of 330, this is also a 30 degree. 30 degree looks like this. So the cosine, we know it's radical 3 over 2. Is it positive or negative? It's in the fourth quadrant. All scholars take calculus, so it is. Oh, what am I talking about? It's positive. It's in the fourth quadrant. It's cosine. 120 is a 60 degree. 120 is in second quadrant. Tangent is negative in the second quadrant, and it's radical 3. Negative radical 3. What is the cotangent of 180? 180 has this order pair. Cotangent is x over y, so it's undefined. What is the y-intercept of cosine x? Cosine starts high at 1 and ends at 2 pi. So at pi, it's at -1. So at the halves, at half pi, it's there. This is what one cosine wave looks like. So when it says what is the y-intercept, it's 1. It's where it crosses the y-axis. I'm going to go down and answer question D since I described this. D says, what numbers does cosine x equal 0? When does cosine x equal 0? It equals 0 at the halves. So you would say at half pi n, where n is odd. Because if it was even, if n was even, that would be 2 pi over 2, which is pi, and that would not be true. It has to be odd, so it's 1/2, 3/2, 5/2, 7/2, all the odds. It's very important that you write odd. For the sine one, here's what a sine graph looks like. So you got 4 hash marks, 2 pi, pi. Sine starts at 0, ends at 2 pi, and has another 0 at pi. So it goes up at the halves and down at the halves. So that's what one sine wave looks like. So for what numbers does sine x equal 0 from 0 to 2 pi? If it's 0 to 2 pi, like this one just said pi over n is odd. If I would have said from 0 to 2 pi on this one, I would have just said pi over 2 and 3 pi over 2, and I would have been done. But I didn't specify on this one, so sometimes you have to say for the general expression, this is a general expression. These are individual answers. So this one, they want individual answers. For what numbers is sine x equals 0 from 0 to 2 pi? So it equals 0, at pi, and at 2 pi. However, depending on if there's an equal sign here or not, if that said less than or equal, I would include 2 pi. If that just says less than, then I do not include the pi. So I'm just going to say 0 and pi. Do you understand that? And what is the y-intercept of sine x equals 0? It is 0. It crosses the y-axis at 0. 16. Okay, so you're going to have to graph this as well, so I don't really have any room to graph this. So I'm going to make my graph up here. Let's see, we have a vertical shift of 2. Looks like everything's going to be high. Okay, so let's get a graph ready. The first thing you want to do with this problem is factor out the 4. It has to be on the outside. So 2 pi divided by 4 is pi over 2. Do you guys understand that? Factor out of 4. So 4x divided by, so it's like dividing this by 4, that's x. Divide this by 4, it's half pi. Bring this out. So this is what you're looking at before you can answer any of your questions. So it looks like 3 is the amplitude. And on the vertical shift is 2. Let's take care of those numbers first. Vertical shift is 2 means that you have a vertical line at 2. So this is 2. This is 1. This is the x-axis. Okay, and then the amplitude is 3, so we're going to go 3 higher than that. Do a dotted line. That's at 5. And it's going to go down to -1. So you're going from 5 to -1. The maximum is from 5 to -1. Now the period has to do with this 4 on the outside. The period is always 2 pi divided by 4, which is pi over 2. So your hash marks should be, the fourth hash mark should be pi over 2. Half of that is pi over 4. Half of that is pi over 8. So if you're going by eighths, 1/8, 2/8, this one should be 3 pi over 8. And it has a horizontal shift of pi over 2. Well, that's what the period is, pi over 2. So once we graph it, if we went pi over 2 to the left, it'd be the same exact graph. So this shift is not going to change things, but it is a pi over 2 left. So basically, after you graph it, it says shift everything back to where it was. Okay. So we're graphing sine. So sine starts at 0, ends at the period, so it's going to end at pi over 2, and at pi over 4, it's going to hit 0, 2. At pi over 8, it's going to be up at 5. At 3 pi over 8, it's going to be down to -1. So you only have to graph one period on the test. Can you see? Oh my gosh, my wand is not even on this paper. So it should look like this. So 0 at pi over 2 at the period, and then half of that, pi over 4. And at pi over 8, it's at 5, and 3 pi over 8 is down to -1. That's one period of it. So if you shifted this pi over 2 to the left, that would go here, this one would go here, and this one would go here. This one would go 4 hash marks, and this one would go 4 hash marks. And it's just the same graph, it just continues it. There's no break in the action because the horizontal shift, pi over 2, is the same thing as the period. So there was no change. All right. That's a big one. That's a big one on the test, so make sure you understand this. Big point one on the test. So 17, write the component form of a vector with a tail at 3, -5. That's the tail. And a tip at 1/8. That's what it looks like. You graph it. And you want the component form. So what did you have to do to go from here to here? Horizontally, you had to do this, and vertically, you have to do this if you're going to make a right triangle. But mathematically, what you do is you go tip minus tail. So we're going to go 1 minus 3. So the x-coordinate of this one minus the x-coordinate of this one, or the horizontal number here minus the horizontal of the tail, comma, 8 minus 5. If you go in the other order, you'll miss it. So basically that is going to be -2. That means that we had to go 2 to the left, and then 8 minus 5 is 13. So you had to go 2 to the left and then up 13 to get to that point. Makes sense, right? 2 to the left and then up 13. It's your horizontal and vertical component. Make sure you write the little pointy symbols. So what is the name of this conic in 18? It is a circle because the coefficients of x squared and y squared are the same. Okay, if I put a 9 here and a 9 here, it's still a circle. So those numbers are the same, it is a circle. Now on this one, there's only one square term. That's a parabola. One square term means one side of it's open. Here's your x squared and your y squared term. Notice they are different, but there's a positive sign. That's an ellipse. And then you have two square terms. One of them is positive and one of them is negative, so that is a hyperbola. So I'm doing an ellipse and a hyperbola problem here. The foci of an ellipse are 2, 4, and 2, -10. These are your F's. These are not your vertices. These, now, if you know your vertices, then you can figure out the midpoint. So the distance between 4 and -10 is 14, and half of 14 is 7. So if you came down 7, there's 4, 1, 2, 3, you would be at 2, -3. So 2, -3 is the center. Okay, so that's a very important number for your equation. And so that means that the distance from center to foci is 7, which means that C is 7. That's not your center. That's your distance from center to foci. That's an important number for your foci formula. Then it says that one of the vertices is 2, -13. So if you went down 3 more, you'd be at vertice. And if you went 3 above this, you'd be at another vertice. So this ellipse is going to look something like this. So what is A? A is a distance from center to the vertice. So from 2, -3 to 2, -13 is 10. And the foci formula is C squared equals A squared minus B squared. C is 7, so that's 49. A is 10, that is 100. You're solving for B squared. So if you add B squared over here, subtract 49, you will get B squared equals 51. That's an important number. If A is 10, then A squared is 100. That's an important number. And the center is an important number. You need all that stuff to write your equation. So it's an ellipse that's vertical. So the bigger number has to be under the y. Keep that in mind. So you can start with the y squared term first if you want, since it's vertical. But I don't. I just make sure that the bigger number is under y. So I'm going to write x. Come here. So we have x center is 2, so x minus 2 squared plus, it's an ellipse, y plus 3 squared. I'm taking care of the center first. So 2, -3 is the center, so that should be -2. If that's a -3, that should be a +3. And then a squared is 100. That's the bigger number that has to go under the y because it's vertical. And the 51 is the smaller number, and it needs to go under the x. And that's your equation. So I have a similar one for a hyperbola here. So we have 1, 3 for one of the foci, and -5, 3 for another foci. I'm going to put F and F. So we should be able to figure out the center. So the distance between 1 and -5 is 6. Half of that is 3. So if we count 3 to the left, we should be at our center. So our center looks to be negative 2, 3. Negative 2 is 3 away from 1 and 3 away from negative 5. This has to open left and right by the way the foci are in the problem. And it says that one vertex is 0, 3. So there it is. That's my vertex. So that's going to open like this. Now, how many units was that vertex from the center? It looks to be 2. That means that A is 2. It's an important number. So if I went 2 this way, that's my other vertex, and it's going to open like this. I have a hole there in my paper, so I can't graph that. So this is a left and right hyperbola, which means x has to go first. A is 2, which means a squared is 4. The c is the distance from the center to a foci, which we already discovered that that was 3. Remember that? C is 3, so c squared is 9. And all we need to do is find what b squared is, and we can write our equation. So the foci formula for a hyperbola is the actual Pythagorean theorem. So c squared is 9, a squared is 4, and we're solving for b squared. So it looks like b squared will be 5. That's an important number. Now, because this is the left and right hyperbola, we want the x to be first. So it's going to be x plus 2 squared. And that's because the center is negative 2. That should be positive 2. Minus, because it's a hyperbola. And then y minus 3 squared. All this equals 1. Now, this time we want the a squared to go under the x because it's opening left and right. So a squared, let's go find it, is 4. And b squared we just found is 5. And that is the equation of your hyperbola. And we're done.